Okay, so now in this video, that means lecture number 9, we will discuss the different kind of program control instruction. Okay, now the program control instruction is actually that category of instruction in which the control of the program in a processor shift to another memory location just by disturbing the normal program execution. Now if you want to learn the different program control instruction, at first you must know what is the way a microprocessor actually executes a program. Okay, so if you just this is your if you just look at the diagram, this is your main memory. You can see that this is your main memory. Different memory block has been identified here. This memory block has different memory address. Suppose this memory address is, let's say this is 50, so this memory address is 51, so next memory address is 52, like that. I have taken a arbitrary address. Now whenever a microprocessor executes the different instruction, there is a register called program counter. Now the function of the program counter is, whenever any processor doing, suppose the processor is executing instruction 1 at memory location 50, then the program counter actually holds the address of the next instruction. Okay, so program counter, whenever the program is actually executing the instruction 1, then the program counter holds the next instruction, that means 51. So 51 will be loaded in the program counter. Next, whenever the program sequence goes into instruction 2, okay, so whenever the microprocessor actually executing the instruction 2, the program counter then holds the next address of the instruction, that means program counter then holds the 52. Okay, so in this way a program is actually executed in a processor. Now this is the normal way of executing a program, one by one. All of the written instructions are executed sequentially, okay, not breaking any sequence. This is the normal execution of a program. Now in this program control instruction, this normal execution of the program, that means first this instruction will be executed in a normal way, next this instruction will be executed, then next this instruction, like that sequentially. But with the help of the program control instruction set, we can change this sequence. Okay, that means if we want, after executing this instruction, the program sequence will goes to this memory location. Okay, then we can get help the different instruction from this program control instruction set. So that is the main concept behind this program control instruction. So this is the technical definition. You can see that it is written over here, that a program control instruction is an instruction which when executed may change the address value of the program counter. The program counter, this is important, program counter, okay, and causes the control of the program to be shifted to some other location rather than next location. That means whatever I am telling previously, that if the program is executing instruction number 2, then the program counter in a normal way holds the address of the next instruction, that means 52. But suppose this is the address 53, 54, 55. Okay, now with the help of the program control instruction, if we want that after executing the instruction number 2, the program will be shifted to address 55, whatever instruction will be written over, that will be executed, then we can get help of this from this instruction set. There are different instructions available for the program control instruction. Okay, and that program control instruction, so program control instruction actually now you will all know that the program control instruction actually shifts the sequence of a program to another memory location rather than the next location. It will not execute the next location, rather than it will goes to other location. Okay, so that is the main concept behind the program control instruction. Now the program control instruction set may be classified into two categories. First is your conditional and second one is your unconditional. Okay, so in the case of the conditional program control instruction, the definition is that it causes the program control to the new address only when certain condition is met. That means suppose we want the program to be shifted to another memory location if the carry flag is set. So that is the condition, carry flag will be set. That means if the value of the carry flag will be 1, then the program will shifted to another memory location. Otherwise the program will execute it normally. So that is called the conditional program jump. That means we have set here a condition that if our carry flag in the processor will be set, then the program will shifted to our desired memory location. But if this condition is not met, that means if the carry flag is not set, then the program will not be shifted to new address, rather than it will execute it sequentially. So that is the conditional program control instruction set. And the opposite definition is actually applicable for the unconditional program control instruction. That means unconditional program control instruction is that set of instruction which causes the program control to be shifted to new address without any condition. Without any condition means we don't put any condition here. That means we just want the program control to be shifted to another memory location according to our wish. There is no condition written over here. Just by seeing the instruction, the program control will be shifted to new memory location specified in the instruction. So that is the two set of program control instructions classification. So you can see that here there are different type of program control instructions are available. Like these two are same actually, jump and branch instruction. Okay, and next set of instruction is your skip instruction. Another, in the case of the stack and subroutine, we have used the instruction call and return. That is used only in the case of the stack and subroutine program. Okay, and next two instructions, these are not too so much popular, that the compare and the test. Compare is actually used sometimes, but test is used very rare. So we'll see these instruction set one by one. Okay, so as the name implies, this jump instruction, okay, jump instruction is actually moves the program sequence to new address location. Suppose if we have written the instruction like that, so the mnemonic for the jump is JMP. So if we written the program code JMP, okay, 55, suppose I have written 55. So after executing the instruction, the program control, that means the next instruction to be executed, will be moved to 55 memory location, and that is the unconditional jump. Unconditional jump means no condition have been checked during the execution of this program. The program will be shifted to this memory location just by seeing that instruction. So that is one kind of branch instruction. Also you can call it a jump instruction. Okay, so here you can also see that there is also as the jump instruction lies in the program control instruction set, also there is two categories available, unconditional jump and the conditional jump. In the case of the unconditional jump, there is no condition have been checked. So that is we have written that the jump 55, the program immediately move to the location 55. And in the case of the conditional jump, this is performed by a set of jump instruction and the condition is specified, and depending upon the condition, the transfer of the control or the breaking the sequence flow and do it by changing the offset value in the that means just by checking the condition specified in the instruction, the program control will be shifted to that memory location. Okay, so here you can see that the example of an unconditional jump. So unconditional jump instruction is JMP, this is the mnemonic, and level is your address. So suppose this is a small program, suppose we have loaded some data in AX, and next we have loaded also some data into BX and also some data into CX. Next we have incremented the ax value by 1, and we have add bx with ax, and shift left operation. Shift left operation I have already mentioned in the logical instruction set, that whenever we logically left shifts any data, then the decimal value of this data is actually doubled. Okay, so this is a small program. And next the instruction, this is important, that means jump L20. Jump L20 means this is your address, so it is again jump into that location. That means this loop have been executed again and again. Okay, that means it repeats the statement starting from here. So this is your unconditional jump. After executing all of the instruction sequence by sequence, after executing this instruction, the program control will move to L20. So, and again whatever instruction have been written here, that will be executed sequentially. So that is your unconditional jump. Okay, so next is your conditional jump. Now the conditional jump, a certain condition have been checked, and if this condition is met at that time of the program execution, then the program control or the program counter will be shifted to the desired memory location. So here are the some of the examples of that instruction. This is your instruction, this is your description, and this is your flags tested. Okay, so jump equal or jump 0. Okay, so here the carry flag zero flag have been tested, that if there is a 0 result have been produced by some any operation, or there is some equal value have been produced, then this instruction have been used, jump equal or jump 0. That means by any means the two operand value are equal, or the operand value of any register is 0, then these two instruction can be used. And jump not equal, that means JNE and JNZ, that's the opposite of that. Next is, this is some kind of mnemonic example, that means jump greater or jump not less or equal. That means jump greater and jump not less or equal. That means if it is not less or equal, then this condition has been made, then the program will shift it to another memory location. Here the flag have been tested is offset flag, sign flag at the 0 flag. And next is your just the opposite, jump greater, okay, or equal. That means jump greater or equal have been tested by J, G and E, this with the help of this mnemonic, and jump not less, that means JNL, with the help of this. And also the sign flag and the overflow flag have been tested here. Next is your jump less and jump not greater or equal. So these are the some of the example of the condition tested, whether the number is greater, number is equal, number is less than or equal or greater than, like that. So these are also some of the conditional instruction set. Here this is the very common example of these two is jump carry and jump no carry. If the carry flag is generated or the carry flag is set, then this instruction can be used, JC sum address. Okay, so if I use this JC sum address, suppose 0001, now if the carry flag is generated, then this instruction, the program control will move to the one memory address. Okay, and this is jump no carry, that means if no carry flag is been generated, then this instruction will be executed. So here all of the instruction you can see that there one condition have been tested. Here is the overflow flag. Overflow flag means suppose I am adding to number, if there is a overflow flag, that means third number have been generated, then this is called the overflow flag. If the overflow flag have been generated here, then this condition have been made, or the no overflow, like that, or the jump parity, jump no parity, jump sign, or if there is a negative value have been generated, this condition can be used. Okay. Some of the example is compare. Compare I will discuss after that of this. Okay, so next instruction is here. So I have discussed the conditional jump and the unconditional jump from that with the help of the different condition. So next we will discuss the skip instruction. Now the skip instruction is that type of instruction when executed. Suppose this is instruction 1, this is instruction 2, and here suppose instead of instruction 3 I have written Suppose instead of instruction 3 I have written skp. Okay, so this is your memory address 53. Now this is some instruction over written over here, some instruction written over here. Next instruction I have written skip. Okay, so if this instruction is written, then program counter will move to next this instruction. If skip instruction is written here, program counter will ignore the next instruction. Okay, it will move to 54. It will skip one address. That is the meaning of that. Okay, so in the normal sequence, that instruction, after that instruction execution, that instruction have to be executed, but with if the script is written here, then program counter will move to 54 rather than 53. So that is the meaning of that. It will skip one address. It will skip one address. So 53 have been skipped. Okay, next is your call and return. Now the call and return actually used in the case of the subroutine. Now what is the subroutine? Subroutine is just a function call. Functions calls means, suppose we have executing some kind of program here. Okay, this is your main program, and suppose we in this program we several times we request the addition of the two number. So somewhere in the stack we have written a function of the addition of two program, 1 2 3 4 line program. Just listen, written here addition of two program, and it will be starting from 60 memory address. Suppose 60 memory address. Okay, so if after that instruction, if I have written that call 60, so it will move to that memory address of the stack address, and whatever instruction will be written over here, that will be executed one by one, and after that it will be accompanied by a return instruction. So return instruction means it will then just return to, suppose this is your memory address 55, call have been written, and next memory address is here 56, so it will just return at the 56. But in the case of the conditional and unconditional jump instruction, there is no way by returning that. Suppose this is your instruction 3 and I have written here jump, okay, and some level, and after that some instruction is there, and this is your level. So jump will go here, and there is no way after executing that instruction, there is no way it can move to here. Okay, so it will not accompanied by any return instruction. It will only move to that desired location. But in the case of the call and return case, the program sequence always return to where it is left. Okay, suppose I am calling that, so it will call to that memory address, and whatever written there it will be executed. Then again after seeing the return instruction, it will again move to that address. So that is the difference between your jump and other jumping instruction, program control instruction, with the call and return instruction. Okay, call and return is always return to the main program at the same address, but here there is no way we can return here. Next is compare. Compare is very simple. Suppose we have two number, this is compare, and suppose we have two number R1 and R2. So these two number have been subtracted, and some condition is checked whether this is greater, it is less, or like that, and if the result is so produced, then we can use the jump instruction. Okay, jump instruction after that, it is accompanied by jump instruction. Compare. And test is actually used for the case of, here you can see this test instruction. Test instruction works same as AND operation, but unlike AND instruction, it does not change the first operand. Suppose I have written here test AL01, so it will just perform the ANDing operation and checked whether the number is even or not. Okay, so if the result is produced, then it will jump 0. If the 0 is produced, that is an even number, then the program sequence will move to another memory location. Okay, so it will not alter the actual operand value, rather than it will affect only the carry flag. Flags only, not the register, any register value. That means if this register will not change after performing this operation, if we here written over AND, then AL value will be changed to the final result. But here if we just perform this test is actually ANDing operation, but this result will not be changed, it will be set to the previous value, and only the flags will be affected. Okay, here the result is 0, then the 0 flag will be affected. So then we can make a condition is the jump 0. If there is a 0, we have said that it is an even number. If it is 1, jump not 0, then it is an odd number. Then we can go to the our desired memory location. Okay, so that is your compare and the test instruction. So these are all of the program control instruction. Program control instruction, so the basic meaning of the program control instruction is that it will move to disrupt the normal execution of the program sequence and move to another memory location. So that is the meaning of that. Thank you.